Welcome back to section 4.2. We're going to be talking about the unit circle. Now, thinking back to our regular triangles, our right triangles, we had that sine, cosine, tangent. Remember, so, ka, toa. Sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. So looking at this triangle given, in standard position, you can see the sine is going to be the y over the radius, the hypotenuse, and so forth. You can read through those. And the cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent, respectively. Now, what we're going to be talking about is what's called the unit circle. And the unit circle is when the circle has a radius of 1. That's why they call it the unit circle. It's 1 unit for the radius. Now, looking at our triangle there, on that unit circle, the sine is still going to be the opposite over the hypotenuse. So it's going to be y over 1, which is just y. The cosine would be the adjacent x over the hypotenuse, which is 1. So the cosine of theta is going to be our x coordinate. And our tangent of theta is going to be the opposite over the adjacent. It's going to be y over x. Keep in mind, x cannot equal 0. Now, the cosecant would be the reciprocal. It's going to be 1 over y. This secant is going to be the reciprocal of cosine. It's going to be 1 over x. And the cotangent is going to be x over y. And for all of those, y cannot equal 0, x cannot equal 0, and y cannot equal 0, just so we don't have that division by 0. And that's for our unit circle. Now let's look more at this. Let's look at it when we have our unit circle. So our quadrants, you see when we're in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So at 1, 0, that's when we're at 0, and then back to 2 pi. So 0 is in the first unit circle. So we're not going to really use that 2 pi, but it's going to go back around the 2 pi. Now, at 0 over pi, we're at 90 degrees, or pi over 2. At negative 1, 0, that's when we're at pi radians. 0, negative 1, that's when we're going to be at 3 pi over 2. So now, if we're looking here at the sine of 0, we're looking at this piece right here. Now, the sine is going to be our y coordinate. The cosine of theta is going to be our x coordinate. And the tangent of theta is going to be our y over our x. So our y coordinate here, the sine of 0, is going to be 0. The sine of pi over 2, it's that y coordinate, is going to be 1. The sine of pi is going to be 0. And the sine of 3 pi over 2 is going to be negative 1. And then we can keep kind of going back. If we go to 0 again, or sine of 2 pi, we're back to that same spot. We're still at 0. If we're looking at the cosine of 0, it's the x coordinate. It's 1. The cosine of pi over 2 is going to be the x coordinate 0. The cosine of pi is the x coordinate. It's going to be a negative 1. And the cosine of 3 pi over 2, it's the x coordinate. It's going to be 0. And if we go back to 2 pi, which is at 0 again, it's going to be 1. And we can also look at the tangent the tangent of 0. That's going to be y over x. So it's going to be 0 divided by 1, which is 0. The tangent of pi over 2 is y over x. It's going to be 1 divided by 0. So the tangent of pi over 2 is actually undefined. And the tangent of pi, y over x, it's 0 divided by -1, it's 0. The tangent of 3 pi over 2 is going to be -1 divided by 0, which is once again undefined. And if we go back to 2 pi, which is still that same spot as tangent of 0, it's 0 over 1, which is 0. But take note that tangent is undefined at pi over 2 and at 3 pi over 2. So on this y-axis, tangent is undefined. And we'll be seeing that more and more as we go through more practice problems. Now, when we're looking at some special angles, we have our 45, 45, 90 triangles and our 30, 60, 90 triangles. So keep in mind, when we talked about geometry, when the legs for an isosceles right triangle were 1, the hypotenuse was root 2. Now, this time, we're not looking at a triangle with a hypotenuse of root 2, but a hypotenuse of 1. So it's going to change things a little bit. So for it to be an isosceles triangle, right triangle, with a hypotenuse of 1, the legs have to be both the square root of 2 over 2. Here we have our old 30, 60, 90 triangle, where the hypotenuse was 2, the short leg was 1, and the long leg was root 3. Now, for our hypotenuse to be 1, our short leg has to be 1/2, and our long leg has to be root 3 over 2. So keep these triangles in mind. Because when we get to other parts of our unit circle with these special angles, the 45s and the 30s and the 60s, that's all based on these right triangles. So, because what you see here, if I draw my triangle right here, this is we're not going all the way to 1. So the hypotenuse is 1, so the legs have to be root 2 over 2 and root 2 over 2. So when we go here, that point is at root 2 over 2, root 2 over 2. That's in quadrant 1. In quadrant 2, negative root 2 over 2, positive root 2 over 2. In quadrant 2, it's going to be the same values, but it's going to be a negative and a positive. In quadrant 3, it's the same values, but both are negatives. And in quadrant 4, the values are the same, and it's going to be a positive and then a negative. And for our angles, it would be our pi over 4. Here, we're going to be in quadrant 2, we're going to be at 3 pi over 4. In quadrant 3, we're going to be at 5 pi over 4. And in quadrant 4, we're going to be at 7 pi over 4. That's for our pi over 4s. Our coordinates are always going to be root 2 over 2, root 2 over 2. The signs are going to change depending on what quadrant we're in. Like I said, it's going to take some practice. Now, the next triangle, when we split it up into 12 parts, when we have our 30s and 60s. Here, looking at the triangle, here's our 30-degree angle. Here's our short leg. This is our pi over 6. So we have is, if we go back, the short leg is going to be that root 3 over 2, and the long leg is 1/2. That's why the coordinates are going to be root 3 over 2, 1/2. I think I said those backwards. And then the next one would be for a 60-degree angle, that pi over 3. The coordinates would go over 1/2 and then up root 3 over 2. Now, as you see, we have our pi over 6, our pi over 3. Then we're going to be at our 2 pi over 3, our pi over 6, 5 pi over 6. Then we're going to be at our 7 pi over 6 here, our 4 pi over 3. We're going to be at our 5 pi over 3, and then our 11 pi over 6. Now, as you can see, all of our pi over 6s, whether it's a pi over 6, a 5 pi over 6, 7 pi over 6, and 11 pi over 6, the x and y values are the same except the signs. In quadrant 2, our signs are going to be negative for x, positive for y. In quadrant 3, our signs are going to be negative for x and negative for y. And in quadrant 4, our signs are going to be positive, negative. And that's going to always be the case. What I always like to do is I make a little sheet, and I know in quadrant 1, quadrant 2, quadrant 3, and quadrant 4, my signs are going to be positive, positive. In quadrant 2, negative, positive. In quadrant 3, negative, negative. And in quadrant 4, positive, negative. That just kind of helps me remember where my values are and what the signs would be. Because all I need to do is I need to think about my first quadrant. In Q1, for pi over 6, I'm going to be at root 3 over 2, and then we're going to be at 1/2. For my pi over 4, I'll come back to that in a moment. And then for my pi over 3, I'm going to be at 1/2 and root 3 over 2. You see how they're the same values? They're just switched. We just switched the x and the y. And then for pi over 4s, it's going to be root 2 over 2, root 2 over 2. So all you have to do is just adjust your signs, and that's going to give you your values depending on what quadrant you're in. Let's do some practice of this. For number 1, we have our pi over 4. So for pi over 4, that's in quadrant 1. And I know for all of my pi over 4s, it's going to be root 2 over 2, root 2 over 2, every single time. So now, my sine of theta is the y. The cosine of theta is going to be x. And the tangent of theta is going to be y over x, every single time. So my sine of pi over 4 is root 2 over 2. It's the x coordinate. I'm sorry, the y coordinate. The cosine of pi over 4 is going to be root 2 over 2 again. It's the x coordinate. And my tangent of pi over 4. My tangent of pi over 4, it's going to be root 2 over 2 divided by root 2 over 2. Now, we're just dividing a number by itself, so it's going to be 1. Now, my reciprocal functions. The cosecant of pi over 4 is going to be the reciprocal. It's going to be 2 over root 2. Now, we do have to rationalize it by multiplying by root 2 over root 2. So you're going to get 2 root 2 over 2, which is just the square root of 2. My secant of pi over 4. Once again, it's going to be 2 over root 2. Now, we already know what that's going to rationalize to because we just did it. That's going to be root 2. And my cotangent of pi over 4 is going to be the reciprocal of 1. So 1 over 1 is still 1. I think we still need to do a couple more to really get our minds around this. For the second one, 5 pi over 3. So we know when we have a pi over 3, it's going to be at a 1/2 and a root 3 over 2. Now, 5 pi over 3, that's going to be in quadrant 4. So I know that it's in quadrant 4. We can see it. That's going to be at a positive and a negative for our y coordinate. That's important to know that just the y-coordinate is going to be negative. So our sine of 5 pi over 3 is the y-coordinate. It's going to be a negative root 3 over 2. Our cosine of 5 pi over 3 is our x-coordinate. It's our 1/2. And then our tangent of 5 pi over 3, it's going to be y over x. Root 3 over 2, negative, divided by 1/2. So to rationalize that, or to simplify that, we don't divide fractions, we multiply by the reciprocal. It's the same as negative root 3 over 2 times 2 over 1. What's going to happen is the 2's cancel. We're going to be left with a negative root 3. And that's the tangent of 5 pi over 3. It's a negative root 3. And now, my cosecant of 5 pi over 3 is going to be the reciprocal of negative root 3 over 2. So it's going to be negative 2 over root 3. When you rationalize, you multiply by root 3 over root 3. Negative 2 root 3 over 3. My secant for 5 pi over 3 is the reciprocal of cosine. It's the reciprocal of 1/2, which is 2. And our cotangent, is the reciprocal of negative root 3. So it's going to be negative 1 over root 3, and we have to rationalize it, multiply by root 3 over root 3. You get negative root 3 over 3. And there's our values. Let's do a couple more. On the next page, please. Pi over 6, that's in quadrant 1. And I know for anytime it's over 6, it's going to be root 3 over 2, 1/2. We're in Q1, so our signs are both positive. So now our sine of pi over 6 is the y-coordinate. It's 1/2. Our cosine of pi over 6 is going to be root 3 over 2. It's the, it's the value of x. And our tangent of pi over 6 is going to be 1/2 divided by root 3 over 2. Now we have to multiply by the reciprocal. It's 1/2 times 2 over root 3. So the 2's cancel. We're left with 1 over root 3. Rationalize, multiply by root 3 over root 3. You get square root of 3 over 3. There's our value. Now our cosecant of pi over 6 is the reciprocal of 1/2, which is 2. Our secant of pi over 6 is 2 over root 3, so we rationalize it. We get 2 root 3 over 3. And our cotangent of pi over 6. Now, if you look, before I rationalized, I ended up with 1 over root 3. Now, the reciprocal of that is easy. It's just going to be root 3. And there's my values. For 5 pi over 4, anytime I see a pi over 4, I know it's going to be at root 2 over 2, root 2 over 2. Now, 5 pi over 4 is going to be in quadrant 2. Once I know that, I know both of the signs are negative. So our sine of 5 pi over 4, negative root 2 over 2. Our cosine of 5 pi over 4, negative root 2 over 2. And our tangent of 5 pi over 4, it's going to be y divided by x. Or the sine divided by the cosine. So negative root 2 over 2 divided by negative root 2 over 2, that's going to be a positive 1. Now our reciprocals, the cosecant of 5 pi over 4. So it's going to be negative 2 over root 2. So when you rationalize it, you get negative 2 root 2 over 2, which is negative root 2. Our secant of 5 pi over 4 is going to be negative 2 over root 2. We already know that that's going to rationalize the negative root 2. And our cotangent of 5 pi over 4, the reciprocal of 1 is 1, and there we go. Now when theta is 0, if we're thinking about our unit circle, is right here, and that's going to be at 1, 0. So there's our coordinates. The sine of theta, sine of 0 is the y-coordinate, 0. The cosine of 0 is our x-coordinates, our 1. And the tangent of 0 is y divided by x. It's 0 divided by 1, which is 0. The reciprocals. Now the cosecant of 0 is the reciprocal of 0. So it's 0 over 1, so it's going to be 1 divided by 0. That's going to be undefined. The secant of 0 is the reciprocal of 1, which is 1. And the cotangent of 0 is still 1 over 0, which is going to be undefined. When theta equals pi, think about that unit circle. Pi is back here at negative 1, 0. There's our coordinates. So the sine of pi is the y-coordinate, 0. The cosine of pi is the x-coordinate, it's negative 1. And the tangent of pi is going to be y divided by x. So 0 divided by negative 1 is 0. Now the reciprocals. The cosecant of pi is going to be 1 divided by 0, which is undefined. The secant of pi, the reciprocal of negative 1, is still negative 1. And the cotangent of pi is going to be 1 divided by 0 again, and that is undefined as well. So if you look there, the cosecant and cotangent are undefined. Problem number 8, pi over 2. Pi over 2, if we're thinking about the unit circle, it's right there, and that's at 0, 1. So for the sine of pi over 2, that's the y-coordinate, which is 1. The cosine of pi over 2 is our x-coordinate, which is 0. And the tangent of pi over 2 is going to be y divided by x. So it's going to be 1 divided by 0, which is undefined. I'm getting these right from those coordinates. Now my cosecant of pi over 2 is going to be the reciprocal of 1, which is 1. My secant of pi over 2, the reciprocal of 0 is undefined, because 0 is on the bottom. And my reciprocal of undefined, remember, the cotangent of pi over 2, the tangent was 1 divided by 0, so now it would be 0 divided by 1, which is 0. So the reciprocal of undefined is actually 0. Now, for 4 pi over 3, whenever you see a pi over 3, remember it's at a 1/2 and a root 3 over 2. Now, we're going to be in quadrant 3, so they're both going to be negatives. So what we have here is that the sine of 4 pi over 3 is the y-coordinate, it's negative root 3 over 2. The cosine of 4 pi over 3 is the x-coordinate. It's going to be a negative 1/2. And the tangent of 4 pi over 3 is going to be y over x, negative root 3 over 2 divided by negative 1/2. We multiply by the reciprocal, you get negative root 3 over 2 times negative 2 over 1. The 2's cancel. We're going to end up with a positive root 3. And the reciprocal functions, the cosecant of 4 pi over 3 is negative 2 over root 3. So when you rationalize it, you get negative 2 root 3 over 3. The secant of 4 pi over 3 is the reciprocal of negative 1/2, so that would be negative 2. And the cotangent of 4 pi over 3 is the reciprocal of root 3. So it's 1 over root 3. So when you rationalize it, you get root 3 over 3. And those are some practice problems of working with these. I'm going to make a video talking about how we can generalize and make some generalized statements based on when we have a denominator of 3, a denominator of 6, and a denominator of 2. So stay tuned for that generalization video. Thank you and have a nice day.